Bismillahirrahmanirrahim. Welcome back, guys. Okay, so we are gonna now look at a very important topic, that is crystallization, which in fact has a lot of questions on your exam papers. If you pick up the last 5 years past papers, you'll find out crystallization in at least every alternate paper, or almost in all the papers you'll find a question from crystallization. So this is that very important. Okay, so please listen very carefully. Okay, so crystallization, what does that term mean? Crystal, the process by which we make crystals. Okay, the process by which crystals are made is called crystallization. That's the simplest definition of all. Okay, but what's the standard definition? Well, standard definition is that crystallization, well, you can't actually define it in a single word. It's actually a process. Okay, and you have to explain that process. But if you need to define it, it is the technique by which we form pure solid crystals from its saturated solution. And what is a saturated solution? I'll just tell you in a bit. Okay, so now let's start out with the chapter, with this technique actually. Okay, so this table has been taken from, again, from the same book, from Chemistry Matters. And after this process, this was the solution that we had, and after crystallization, this is what we will have. Okay, so now stick around and don't go anywhere. Let's get started. Okay, so the best method, okay, the book says it, I don't say it, the book says it, the best method of obtaining a pure solid sample from its solution is called crystallization. Okay, so on the exams, if you're asked which is the best method, or which is the purest solid that you could obtain, or which is the purest crystal that you could obtain, by what technique can you obtain that? So you can obtain that by crystallization. Okay, excuse me for right, guys. So how do we purify by crystallization? So now let's see, how do we make pure crystals, and why are they so pure, and why are they crystals, by the way? So let's answer all of these questions over here. Okay, how do we purify crystallization? I'm just gonna quickly read through this and then explain them. In crystallization, water is removed. Okay, by heating and the solution. But that's the same thing that happens in evaporation to dryness. Then what's the difference in between that and this? Now let me continue. Heating is stopped at a stage when a hot saturated solution is formed. Okay, what is a saturated solution? Now this is a point that you need to understand, so listen very carefully. What do we mean by saturated? In our daily life, what does saturated mean? Saturated means full, right? Something that is full to its full capacity. To its capacity, it's full, right? That means saturated. Like, for example, if we have a workforce of a few laborers and they are doing their work which they are supposed to do, and every labor is busy in that work, we say that the labor force is saturated. So the same goes over here. This solution that we have, it is saturated in the sense that we are actually removing out solvent from it, right? Heating it, evaporating it means that the concentration is rising. The concentration is rising. Remember what concentration was? Concentration was the amount of solute present per unit volume of the solvent. So if per unit volume of the solution actually, so if concentration is increasing, it will reach to a point when the solute particles would become more than the solvent particles to accommodate. What do I mean by that? Well, listen, guys, listen very carefully. Solvent, the quantity of solvent that we have, for instance, if we have, let's say, 50 grams, just assuming 50 grams of water, okay? And let's say this 50 grams has the capacity to dissolve 10 grams of sugar. Just assuming, okay? This is not the actual stats or the actual values. These are not the actual values, but just assuming it, that the 50 grams of water have the capacity to dissolve 10 grams of sugar. If instead of adding 10, I add 20 grams of sugars, that means I have saturated the solution. That means I have added solute more than the capacity of the solvent to accommodate, right? That's what saturated means. But now you can saturate a solution by using two methods. Number one, either you increase the quantity of the solute, either the solute's quantity increases. So again, its quantity will surpass the ability of the solvent to accommodate it, right? So we'll form a saturated solution. Or the second method is the one which is given over here. If instead of increasing the concentration or increasing the quantity of solute, you decrease the quantity of solvent. If you decrease the quantity of solvent, again you'll decrease the capacity of the solvent to accommodate the solute, and now you will get a saturated solution. Saturated solution in simple term means a solution that can no longer accommodate or dissolve more solute. That's what a saturated solution means. Simple. I hope that is. And by the way, guys, saturated solution, this term saturated solution, this is a key point, and it has a separate 1 mark in your answer while you are explaining the process of crystallization. So do not skip this point. Otherwise, you won't get 1 mark. Okay. I've gone through tons and tons of marking schemes, and in almost all of them, they had the mark of for saturated solution separately. Okay. If the resultant solution is allowed to cool to room temperature, the dissolved solid will be formed as pure crystals. Okay, what do we mean by that? Okay, now listen, guys. Once you heat the solid, once you heat the solution, and as soon as you heat the solution, you remove out the solvent. And approximately when 50 to 60% or 70% of the solvent is removed by or is evaporated, then the solution which is left behind, it's a saturated solution. Okay, now this saturated solution, while it is hot, it won't show any solid particles because it's hot, right? Whenever a solution is hot, it can accommodate whenever a solution is hot, it can accommodate more of the solute. But as soon as it starts cooling down, as soon as it starts cooling down, the molecules start coming closer to one another. Why can hot solution accommodate more solute? Because in hot solution, the particles of the solute and the solvent are actually far apart from one another. So there is a lot of space in between them. But as soon as it starts cooling down, the solvent starts cooling down, the solution starts cooling down, then what happens? The atoms or the molecules of the solvent starts coming closer to one another. The molecules start jumbling up, start coming closer to one another. They start uh, uh, converging at certain points. And as soon as they start coming closer to one another, then what happens? The solute can no longer, there is no longer space available for the solute to remain dissolved in the solution. So what happens is that the solute, it precipitates out as crystals now. Okay, why does it precipitate out as crystals? Why not powder? So the answer to that is because the water which was left behind after evaporating out the solvent, the water left behind after evaporating out the solvent, that allows it to form crystals. Why do we have crystals? Because of water which is over there. This water has a special name. What is the special name given to the water? It's called water of crystallization. Okay, it's called water of crystallization, and this is again an important point because without the water of crystallization, you can never have crystals. Okay, the blue color, well, the blue color doesn't matter because it's actually due to the copper ions in there, but the crystals are formed and no powders are formed is because of water of crystallization in there. You know what? If you heat these powders, if you heat these crystals, the water of evaporation, the water of crystallization would evaporate out. And as soon as the water of crystallization evaporates out, then what happens? You're left with powder. Only powder is left. So hence, proving the fact that water of crystallization is needed for crystallization. But anyways, this was the detailed concept of crystallization. Now, how do we test for saturated solution? This heading over here, I have added this because this is a valid test, and yes, you can use that to test for whether a solution is saturated or not. But guys, um, I won't explain this because this isn't asked that frequently on your test, okay? But still, I'll just go over it, okay? A clean glass rod, glass rod can be used, okay, to test for crystallization, to test for a point of saturation or the point of crystallization. Point of saturation is also known as point of crystallization. Point of saturation is that point when a saturated solution is formed, okay? And you know what saturated solution is: a solution that can no longer dissolve more solid, okay? It can be used, a clean glass rod can be used to test whether a solution is saturated or not. It is dipped into the solution and then removed, okay? The clean glass rod is dipped and removed, and as soon as it is removed, what happens? The solution which is taken out on the glass rod, it cools down, and as soon as it cools down, you, on the tip of the glass rod where you have drawn out that small amount of solution, you will find out small crystals appearing, and that will prove the fact that yes, your solution has become saturated, okay? There will be a small amount of solution on the rod. If the small crystals form on the rod as the solution cools down, the solution is called saturated. We say that the solution is at the saturation point or at the crystallization point. Clear? So this is just one way of testing whether a solution is saturated or not. But guys, when you heat a solution and more than 70 to 80% of the solution evaporates out, then definitely that solution is saturated, okay? You don't need to go with the glass rod and stuff, okay? Now, what do you need to write on your exam paper when this question of crystallization comes? How to obtain a pure sample of crystals from a solution of copper sulfate. So now guys, I'm listing these points and listen very, very carefully. The very first thing that you are going to do is, the very first thing is heat the solution, okay? Heat the solution. As soon as you heat the solution, then what happens? The second step is you wait for the solution for more than 60 to 70% of the solution to evaporate out. As soon as that happens, a hot saturated solution is formed, and you need to mention this term, hot saturated solution. You need to mention this term, okay? You need to mention this term, saturated solution is formed, because this term has a separate mark. If it's a 3-mark question, 1 mark is for the saturated solution word. As soon as a hot saturated solution is formed, then you allow the sample to cool down, okay? You allow the sample to cool down, and as soon as the sample is allowed to cool down to room temperature, crystals appear of copper 2 sulfate, and as soon as you get the crystals, these are the 3 marks you got for the process of crystallization. But usually this question is for 4 marks, and what's the 4th mark for? They ask us how to obtain a pure dry sample of copper 2 sulfate, right? So to obtain a pure dry sample of copper 2 sulfate, the 4th mark is you filter the solution. Okay, remember filtration process. Remember the process of filtration that we did. You filter it out. Okay, what do we mean by filtration? Have we did the entire process in the previous videos? You can just refer back to that video. Okay, you filter out the solution, and as soon as you filter that out, you will get the crystals as a filtrate or a residue. I'm asking this question, filtrate or residue? Of course, the residue, okay, not the filtrate. Filtrate is the liquid portion, residue is the solid portion. The residue will be left on the filter paper. And as soon as you get the residue, the crystals are on the filter paper, then what do? You wash them with distilled water to remove out any impurities, and then you dry them in between a few sheets of filter paper, or you heat them in an oven so as to dry them, and then you get a pure dry sample of crystals somewhat similar to these crystals. And this is the entire procedure by which these crystals are made, okay? So just let's sum it up by using this diagram. Copper 2 sulfate solution, you had the solution, you heat it till the saturated point, okay, meaning more than 70 to 80% of the solution is evaporated, or you heat it till saturated solution, till a saturated solution is formed, or till the saturated point. Then the saturated solution is allowed to cool down, okay? You allow it to cool down, and as soon as it cools down, you get the crystals and the solution which contains soluble impurities, okay? The solution will contain insoluble impurities, but the crystals are going to be pure, Okay, they won't contain any impurities. And then you filter the mixture, and as soon as you filter them and then you dry them and then you uh, dry the residue, you'll get your pure crystals of copper to sulfate. And this in detail covers each and every aspect of crystallization. And by the way, guys, this topic is an extremely high yielding topic. Do not risk yourselves by not reading this topic, by not learning this topic, okay? And you will definitely find tons and tons of questions related to this topic being asked on your past papers. Now the next thing is key ideas, and we are done with the first type of technique. The first type of technique, remember in the previous videos I told you about the techniques of separation and purification. This was the first type of technique, which stated separating a solid from a liquid. So we did decanting, we did filtration, we did evaporation to dryness, and now we've done crystallization. These are the four ways by which we can remove solids from solution. Okay, the solids can either be insoluble, so we have to use decanting or filtration, or if the solids are soluble, we are either going to use evaporation to dryness or crystallization. And the purest of all, the purest sample of crystals that we are going to get, or the purest sample of uh, solids that we are going to get, are going to be the using the crystallization technique. And I hope this covers up everything, and I hope if you have any doubt, you are always free to leave it in the comment section. Okay, and then in the next video we're going to talk about solids, and then liquid from solution, and then liquids, and that's it. So stick around, guys, till the next video, and till then